that the condition f of a plus v, f of a, f of v vector for every a belong to affine space A and every v belong to vector space E vector can be stated equivalently as f of x is equal to f of a plus f of a x, or f of a, f of x is equal to f of a x. For all ax belong to E lemma 27 to show that for any affine map f of E there are points a belong to E, we belong to E prime, and a unique linear map f E from E to E such that f of a plus v b plus f of v vectors for all v belong to. Already, dear student, I have taught you in class that any affine points can be written as, say this is b, which can be written as s by translation. Any point can be translated by a small a. On for all v belong to E, just b is equal to f of a, and any E belong to affine map for which is the identity map are affine map for which f vectors is the identity map are called translation. Indeed, if f vector is equal to id, f of x is equal to f of a plus f of ax, f of a where f of ax is equal to ax, taking common f of a is equal to x and to xa, this can be written as xa plus a prime plus a f of a plus ax. So x plus x of a plus a f of a minus x a x, so a f a and so on, x f of x is equal to x f of x is equal to a f f of a, which show that f is the translation induced by vector a f of a, which does not depend on a. Since in affine map preserving barycenter, and since in affine vectors with subspace V is closed under barycentric combination, the image f of V is in affine subspace in E prime. So, for example, the image of a line is a point, a line, and the image of a plane is either a point, a line, or a plane. It is easily verified that the composition of two affine map is an affine map, also given map. And now we take a particular example. Consider we have two functions g and f. We want to composition of this vector in affine geometry. F from E to E and G from E prime to E double prime. We have, this is integral equations which show that GOF and GOF. It is easy to show that an affine map f from E to E is injective epenulep f of E into E. Now you know that injective means 1 and that f from E to E is f from E to E is a surjective epenulep f from E to E is effective, and that if f of f from E to E prime is the surjective onto f and f from E vector space to E vector space is surjective. An affine map f from E to E prime is constant. F and f from E vector to E vector is the null constant linear map equal to 0 for all v belong to. Let E is an affine space of domain M, and these are the points is in affine frames per E. Then for any other affine space f and for any for any sequence b0, b1, bm of m plus 1 points in f, there is a unique map f from E to E, from E to f, such that f of ai is equal to bi for 0 less than less or equal to I less or equal to m. Indeed, f must be such that f of lambda naught a naught lambda m where is equal to lambda naught b naught and lambda m bm, where the summation of this coefficient is equal to 1, and this define a unique affine map on all E, since this is the required symbols. Similarly, using affine frame, affine map can be represented in terms of matrices. In terms of matrices, we can also represent these. Here, f from E to E is f is represented with respect to two affine frame, a naught in E and b naught b1 in f being analogous. Thus, since f of a naught plus x is equal to f of x, f of a naught plus f of ax vector for all x vector belong to E vector, f of a naught, f of a naught plus x a naught, f of a naught plus f of x. Now, since x a naught, f of a naught, and f a naught, f of a naught, summary if and f of a naught can be expressed as x is equal to x1 a naught a1, xn a naught a naught f of a naught b1 a naught a1, bn a naught an, and so on. Since fa we use a is equal to ai, j is the m cross n matrices of the linear map T over the field over the basis a naught a1 a naught an, letting x y and b denotes the common vector of the components x1 to xm, y1 to ym, and b1 and to bn. Can be written as a naught f of a naught plus x a naught f of a naught plus f, which is equal to y is equal to ax plus b, where b is not equal to 0. Similarly, another example here he take this is x and uh, this is a b with translation 1 0. This map is a reflection about the x-axis by a translation along the y-axis. Along the x-axis, the affine map x1 x2 into 1 into 3 under root by 4 minus 3 under root by 1 over 4, and this can be written as in this way. Consider another example. In this example, this is a affine vector which can be accommodated to affine spaces S. Has no such on the other hand, the affine map has no such a point, even though even though this is the required table. And the second matrix is a rotation. Here the second matrix is a rotations of theta such that theta is equal to 4 over 5, theta is equal to 4 over 5, and theta sin theta is equal to 3 over 5. For more on fixed point of an affine map, see the problems. Here you know that fixed point is equal to f is a functions from say real line to real line. F of x is equal to f of x is equal to say f of x is equal to I define a map as a affine map. This trick is very useful in kinematics and dynamics, where A is a rotation matrix. Such affine map are called rigid motions. F from E to E is bijective affine map given any three collinear points. We take here three collinear points A, B, C, and E, where A and B not equal to 0. We say C is equal to 1 minus lambda A plus lambda b. Since f preserve the very center, we have f of c is equal to 1 minus lambda f of a plus lambda b, which show that f of a, f of b, f of c is a is we have f of a 1 minus lambda a plus lambda b, which show that if f of a, f of b, f of c are collinear in E prime. There is a converse to this property, which is simply to state when the ground field is k is equal to real. When the field is k real line, then the converse of such results state that given any bijective function f from E to E prime between two real affine spaces of the same dimension n greater or equal to 2f maps any three collinear points to collinear points, then f is affine space. Here this is an interesting ratio formula. Consider we have 3 point A, B, C in which A and C are not equal to C. Now the linear combination of B in terms of A and C where we have b is equal to 1 minus beta a plus b beta c for some unique beta, and we define the word d the word we define the ratio of the sequence a b c d as ratio a b c a divided by beta divided by 1 minus beta, which is equal to a b vector divided by beta. This is the required lecture of affine geometry. Dear student, you can now define, we come in positions that we can define affine grooming and other etc. Thank you.